Hello guys, welcome back. Now let's have a look over our new gyroscopic sensor that will be L3G4200D. And for that, we need to visit the website that will be controleverything.com, and here we have the sensor as you can see on my screen. It's a MEMS motion sensor, ultra stable 3-axis gyroscope, and also some more features are onto the screen, and you can also purchase the sensor from this website. Also, I will be interfacing the gyroscopic sensor L3G4200D with a BeagleBone Black, and the software platform I will be using is a C language code. And get on to the resource tab, and here we have the C code sample onto the screen. Now you can download the C code sample onto the screen from this website as a zip file right here. And also you can get the code from github.com, and the concerned repository there will be Control Everything community. Now let's have a look over the hardware connections and let's proceed further. Well, for the hardware connection setup, the first thing we require is the BeagleBone Black, which you are able to see on my screen. And this here is an I2C Shield for the BeagleBone Black. Now this is available on the website controleverything.com, and the real reason we are using this shield is to make connections easier with other I2C devices. So for that, what we require is to gently place this I2C Shield over the BeagleBone Black and make a connection just like that. For the power up setup, we require two things. The first is a mini USB cable just like this and gently insert it over here. It is very useful to power up the BeagleBone Black. Now to power up the I2C Shield, we require a 5-volt adapter, which you are able to see on my screen, and gently insert it here. Now for an option for the internet connection, there are two mediums. The first is an Ethernet cable or a LAN cable, and the second is this, a wireless nano USB adapter. Now this here is our sensor gyroscope L3G4200D, and this here is a connecting cable. Now make the connection among the sensor and the cable, and make sure that the brown wire of the cable should be connected to the ground terminal of the sensor, and similarly to the ground of I2C Shield. So we are done with the hardware connections. Now let's have a look over the code we need to interface. Regarding the interfacing part, first of all we need to log into github.com, and after that we have to search on for the repository, which is Control Everything community. After getting there, we have the sensor that will be L3G4200D, and it's a gyroscope, and this comes the C code. Now let's have a look over the instructions part. As you can see, we need to set up our BeagleBone Black, and the steps are on beaglebone.org. Let me open up this link for you, and as you can see, we have a several step procedure for the proper setup, and do it carefully. And after that we need to download the code onto the BeagleBone Black, and this command will compile and this will run the C code. Note it down carefully, which we will use later in the working part. And this comes the C code, and it's a .c extension as you find. And also you notice that we have included some of the header files here, first thing you notice. And in the void main function we have to check the I2C bus is open or not, and we have to get the I2C device, and the address of the sensor connected will be 0x68. Now coming to the writing section part, we are going to select the register configuration register 1, and we are going to set the command for enable XYZ axis, disable power down mode, that will be 0x0f. And after that we are going for the control register 4, that will be 0x23, and we are going to send a command for full scale range 2000 dps, that will be 0x30, and here it is. After getting that, we have a delay of 1 second, and then we are going to read 6 bytes of the data, and after that we are going to read it serial wise like that. We are going to read x-axis LSB first of all from the register 0x28, and as you can see this is the command here. And after that we are going to read MSB of gyroscopic data for x-axis from the register 0x29, then data from Y and Z axis, similarly like that. After that we have the conversion of the data takes place for gyroscopic X, Y and Z axis. We have the conversion formulas applied from the data sheet for L3G4200D. At the very end, as you can see, we have the output data onto the screen, which is the rotation in X, Y and Z perpendicular axis. And let me tell you, these values are the raw values, which can be negative, positive depending upon the rotation motion. So this is how the code is. Now let's see how it works. Now let's have a look over the working part, and the to check the practicality, first of all, we need to copy the entire code of this sensor, and after that we have to open up the terminal for the BeagleBone Black, and we have to name the sensor as you can see on my screen. And let's see what we got here. L3G4200D is the sensor name, and .c will be the extension of the file, and here we have to paste the entire code, and after that we need to save it. Now for the compilation step, let me tell you, this is the command, and the full command is here, and after that this goes and we have the successful compilation of the code. Now for the building or running the code, this is the command we need to follow, and we have the rotation in X, Y and Z axis, because the angular acceleration is onto the screen and we have the values onto the monitor. But when I run the command and when I try to rotate the sensor, you can see the changes are reflected onto the screen, which are the rotation in X, Y and Z axis. And when I move the sensor in different directions, the angular acceleration regarding the changes for X, Y and Z axis are reflected for all three perpendicular axes. So this is how the sensor works. Now let's have a look over the applications and benefits. The L3G4200D is a low power 3-axis angular rate sensor able to provide unprecedented stability of zero rate level and sensitivity of temperature and time. It includes a sensing element and I2C interface capable of providing the measured angular rate to the external world through a digital interface I2C or SPI. The L3G4200 has a full scale of plus minus 250, 500 and 2000 dps and is capable of measuring rates with a user-selectable bandwidth. The applications are gaming and virtual reality input devices, motion control with MMI, GPS navigation systems, and appliances and robotics. Well, you can have this sensor and you can purchase it from controleverything.com, and you can get the code from resource tab. From this site, you can download the code as zip file. Also, you can get the code from github.com, and the repository there is Control Everything Community. In the end, I would like to make it clear that if you have any doubt regarding any part of this sensor or video, you can have your queries on controleverything.com, and you can post your comments on the community page on this website. For articles and blogs, you can have a look over on instructables.com, and to subscribe more video tutorials like this, you can have a look over our YouTube channel. In the end, I hope you enjoyed this video and had a good one yourself. Thanks a lot for watching.